boring. It's going to vertically bore a damaged port because the threads are shagged. Doesn't look too shagged there, but if you look there, it's a UNO port. It's an 1 1/16 UNO port, and we are going to bore it to 1 inch BSP parallel. So this is a vertical mill, and we're going to change the chuck here. We actually use this mainly for drilling, but we're actually going to convert this. This is actually a milling drilling machine, but we're going to actually convert it into a vertical boring machine by changing this attachment. And then we're going to actually mount this in here and then vertically bore a larger size hole so that we can cut another larger thread and save this housing. Now if you're in the US or in continental Europe, you could probably just buy this part from a number of manufacturers. I mean, this is made by Galtech in Australia. Galtech in Italy, I'm sorry. We can't buy just this part. So we tend to compromise, modify, and do what we have to do to make shit happen. So what you're seeing tonight is how we make shit happen. Yeah. It's normal.
Ready?
That's just normal. Well, it's pretty impressive, eh? And what's its purpose?
That's to bore something vertically in a mill.
What are we
Very accurately.
So what are we boring vertically in the mill today?
A housing,
From?
a pump.
What kind of pump?
Don't know.
It's boring. It's going to vertically bore a damaged port because the threads are shagged. Doesn't look too shagged there, but if you look there, it's a UNO port. It's an 1 1/16 UNO port, and we are going to bore it to 1 inch BSP parallel. The beauty about this is you can do very small holes by installing these cutting tools. So if you put it in here, you can cut a very small diameter hole. You have certain adjustments with this here. When you turn that, it offsets that. Put the Allen key in there and just show them what happens. It's quite firm.
As in back?
Yeah, either way you go. As you rotate, see how this is offsetting? See how that offsets as you rotate it? So that's actually moving that in that direction, which means it'll cut a bigger and bigger diameter incrementally. You can also put it here, and that will rotate that way, which will cut an even bigger diameter. And if you want to do a really big hole, you can put it here. You can put it in there, which will cut a massive hole. And if you want to do a really, really big hole, yeah, you can put a bunch even bigger.
You'd have to run at a slow speed though, because it would shut up.
Yes, you need to run at a slower speed.
It's damaged.
It's not damaged, they're just bored very, very precisely. Anyway, that one's not going in, but we can make it go in. However, what we're doing today, chances are we will just be using the middle hole.
There's so many.
All right. So how far down are we going to go, Seth?
We're going to be going down if we get our vernier.
Just come from here. Yeah. We want to go down from the top, but we want to leave at its minimum depth, at least 3 mil. Just go down until you touch my finger. Hang on a second. Can't even get in there. Just keep coming down. Keep coming down, keep coming down, keep coming down. I'll tell you when to stop. Okay? Stop. What's that depth?
30.53 millimeters.
30.5. Let's remove a minimum, a max of 3 millimeters from that. You want to leave 3 millimeters of shoulder.
So we'll be
30.5 minus 3.
We're going to be cutting 27.
So our depth of cut is no more than 27 millimeters, yeah?
Yeah.
On the top here. All right? What we also need to do, this flat face here, we need to actually machine that just a little bit bigger, because the fitting we're going to put in here
Got a bigger down
is got a slightly bigger
big O-ring.
ceiling, needs a slightly bigger ceiling face than what's currently here. So we also need to cut a new ceiling face here as well. All right? But the first thing we'll do is put this in. So what we're going to do now is drop it down, move this above this ball, and then we'll slowly rotate, yeah? And slowly increase the diameter to self, and then we'll adjust the top slide and the cross slide until this tip is just skimming equally all the way around the ball. All right?
Yeah. So today we're going to be cutting a 1-inch BSP internal thread, and we must find the boring size before we cut the thread. And we go to our chart here, and we've got our BSP chart, and it gives us our imperial sizes. We're looking for 1-inch BSP today, and we want to know what we need to actually bore our hole out to. And if you look at the tapping drill size, it'll say 30.75 millimeters. And if you were to be cutting an external thread, your threads per inch would be 11 on your lathe. On this dial, on our dial, the on our up and down dial,
Yes.
each increment in between 10, 20, 30, 40, etc. is 0.02 of a mil. And a full revolution is 4 mil, because if you get 200 is a full revolution on our dial, and you times that by 0.02. I did that like backwards.
It's fine, keep going. You're doing great.
Equals 4 millimeters.
Correct.
So a full revolution is 4 millimeters.
Right, so if we want to go down 27 millimeters maximum, how many revolutions is it?
6.75.
Alright, so on the dial, we'll go 6 full turns, which will get us close, and then we've got to go 0.75 of a turn.
Yes.
Right? So 0.75 times the 200 graduations is how many graduations?
150 millimeters.
150 graduations, not 150 millimeters. That's 150 millimeters.
Yes.
We want about 3 millimeters. Yes. All right. So we're going to take a very light cut. Okay, you're going to start at 0. All right. We're going to start the machine. Make sure it's not vibrating too much, because what we've started to do now is we've actually got an unbalanced load when it's rotating now, so it might vibrate a little bit. Okay. That's locked. That's locked. That's locked. We're ready to start. Hit the start button, and then we're going to go 6 turns, and then 150. Okay?
Yeah.
All right. It has to be nice and smooth. Ready to go.
Yeah.
All right. So if we look at this here, all right. What numbers do we have here? We've got from 10, 20, 30, 40, 50 up to 100.
Yep.
And each graduation is 0.01 of a millimeter. All right?
Yep.
So one full revolution is 100 times 0.01, which is what?
1.
Confirm it.
So, according to our calculations, 100 times 0.01 is in fact 1
All right. So 1 what? 1?
millimeter.
Okay. So if you go a full turn on that dial, it's going to bring this out 1 millimeter, which is going to do what when you actually rotate it a full revolution? It's going to take what?
It'll take.
It'll take double the movement.
Because it's not
All right?
coming off the.
So if you go 1 full revolution, you're going to move this out 1 millimeter, which means it's going to cut 1 millimeter off this side and 1 millimeter off this side.
Yes.
All right?
Yeah.
So you're going to increase the diameter by 2 millimeters.
Yeah.
Correct?
That's right. Yeah. So we have to go.
We
half
were
of
at
that.
what? 26?
We were at 20. No, we were at 20. Yeah, 26.
Sorry, 20
1.
26.51
So we
plus
need
2.
4.12.
Just take another cut because it's only 2 millimeters.
We can't
Alright.
take a full 4.2 cut.
Just take one. No, we're not going to take 1 full cut. Okay, we're going to
Yeah.
We're going to go a full revolution and then take a 1 millimeter cut. All right. Now, as you can see, yeah,
If it's at 26.5, that means we need to be.
bring that over
4
there.
point-
So you're not going there. Bring it here.
2, 4.
Just take 1 cut because it will take you from 26 to 28. Right?
Yes.
Good. Beautiful material, isn't it? Machined so beautifully.
You didn't move? No, you didn't move that out, did you?
I haven't moved anything.
No.
have you?
So
You have to go. Which way are you going?
we're gonna have to go back that way because we're gonna bring it in.
Okay, so make sure.
So it's set on 0. If 1 full revolution.
Are you going in or are you going out?
I'm going up into.
What's happening to your tool? Watch your tool. Which way did you just go?
Hold up, let me see. No, that's right. What I was doing was right.
Okay. So which way are you going? You're going anti-clockwise to bring it out. Remember, you can't go back. You've got to go quick, gently to the right position. All right? So you've got a full revolution.
Yeah.
Does it look like you're going 1 millimeter? I don't know. Start your flywheel. And then you're at 0.
I'm gonna get it. Here, it's actually. 0 now.
Okay. Go. That's what you're doing. That's your work. You've got to go 6 turns. Just remember, at the top there, you've gone 1. You're going to go. All right. See, as you drop it back out, there's still a little bit of flex there. So when you're dropping back out, drop out a little slower because it's still taking a tiny cut as you drop it back out. All right.
Yeah.
Okay. So when you drop it back out, drop it slowly. All right.
Yeah.
So where are we at? Double check. tighten them up so they don't actually move, and then you
Yeah.
put them into the hole diagonally. Yeah, and then you actually straighten it out, and then you pull it out, and then you measure that. So measure this. What are we at?
.6.
Sure.
I think mine's more. Yeah, I was going to say, I think
Told you this.
target ID
30.75, and we're currently at 28.7. So what's left?
One more mil. 1 point.
Don't guess. I don't want you to guess, because you're crap at math.
No,
All right.
incorrect.
30.75. What did we just measure?
It's 1 mil.
What did we just measure? What did we just measure? Write it down.
I just wrote it there.
But that's not correct. He's 28 points. What's the target?
30.75.
Enter that first.
30.75 equals. Because it was half a mil.
Where does he get his numbers from? He just pulls them out of the air. You pull them out of the air.
Made
What I'm trying to
measurements.
get you to understand is, what did you do here? I
only
told you
did
to
it
go
half a
50.
turn.
So half a turn is meant to do what? Half a turn moves this out how far? 0.5 of a millimetre. So it's going to take 0.5 off this side plus 0.5 off that side. So it should have taken a millimetre
Did I just
off this
say that?
diameter. So we've got to go 55 and a half more little graduations. Okay? So we're going to go we're going to go to where? We're going to go to 0, and then we're going to go another 5.
Yeah.
All right? Okay? Remember, you can't go back. You can only keep going forward.
Oh, that's lucky, eh?
Is that 0 or is that at 5?
That's it. 5.
All right? Start up, do your final cut.
So we got the right measurement.
There we go.
Thank God for that.
Cut a thread into here so we can fit this fitting into there. All right? This recessed area here is called a spot face. All right? I don't believe the spot face is big enough in diameter to take. See that? We're a little bit out. We're at 42.9, and we should go to about, just to be on the safe side, 45.2.
What was your first measurement?
42.5.
Take what do we want?
45.2.
32.7. So
Where are we at now? We're at 30.73 and we've got to go out to 45 point.
we go out to, this is for the face, isn't it?
Yes.
Yeah.
But we know what this diameter is. How far out more do we need to go? I'm just not sure we can do it. We might.
14.5.
14.5 divided by 2.
7.25.
We've got to go out 7.25 millimeters, right? So, which is basically 7 turns plus a quarter of a turn, correct? From where we are now. Just check the diameter.
Is this someone's job? So I'll be billing you?
But hey,
I'll be billing you?
you know, this is a job we're doing free of charge as a training exercise for you. Alright, so we've got some clearance now. Alright? It's 45. That stays vertical later, you do it up with the... A couple of turns.
Go one more turn, then I'll come back. And then I'll stop and then break the burr on the way back. Because it's not
Just wait there a sec.
it's not a machine tap, which is a fluted machine tap.
Beautiful. Beautiful. So you can lock this up in any position. Okay. Job well done. So now, what do? We assemble the pump. Or do you want to have some lunch first?
Yeah, I'll be on
Lunch. see the marks. This is the shaft side, so this side needs to be really well aligned so that the shaft comes through here. So those little marks need to have dowels put into them. Alright, so push those little dowels. People understand this is the pressure port.
So why don't we stamp it?
So if you look at that,
Oh, that means pressure, doesn't it?
right, that arrow is saying rotation. So what that means is the rotation is correct. So if you look in the gear, right, see the arrows pointing down and you rotate in that direction, yeah? If you look in here and the gears as they're rotating are coming towards you, that means it's actually sucking because it's
Yeah, because it's pulling
going
the
in
oil
there and then the oil's going around the outside on this side and the outside on that side, all right?
So when it's going out the other way, it means it's
All right,
pushing.
and then I'm still rotating the same way. All I'm doing is coming to this side, still rotating in the same direction. See how the gears look like they're meshing together? That means that's the pressure side. That's discharging oil.
Oh, because it's coming around the side of the actual.
Because the oil's coming
grooves
around the
around
outside. The
outside.
oil can't go down the middle because the gears mesh together. There's no way for the oil to go
Yeah.
down the middle. The oil has to come out and out this way. Do you get it?
Yeah.
So this is the pressure port. All right. So we're going to get a letter stamp and actually put a P here for pressure, and then we're going to stamp the other side S for suction, so nobody can stuff it up.
I'll go do that now.
Okay. Okay, you.
I am a fitter.
All right, there's the P. All right. For pressure. You can do the S. Put the S on that side there.
On that side or that side?
Oh, there. Okay. I would have put the S that way rather than that way, but you know.
Right.